Welcome back again, class. Today we're going to finish off the section 8.5 on adding and subtracting rational expressions. Now, just a really quick review on what I mean by adding and subtracting rational expressions. So remember, looking at this first piece, looking at that, the first thing we should be concerned with is if anything factors in the denominators. So if you notice, one of our pieces does in fact factor. This one factors to x minus 2, x minus 1. And remember, when we're adding and subtracting these rational expressions, we need to find a common denominator. So what that means for us is every piece needs to be represented in this common denominator. So that means this one is already complete. It has both pieces of our common denominator. However, this one is missing the x minus 2. So I need to multiply top and bottom by that x minus 2, the one that it's missing, so it can be complete, so it can have it. So what that means is from that first fraction, I'm getting the x times the x minus 2. The second one actually isn't changing at all. So that means I'm getting x squared minus 2x when I distribute that, plus 2x minus 1 over that same denominator. Now, when I go to simplify the top, well, a minus 2x plus 2x, I cancel that off. So I have x squared minus 1, x minus 1, x plus 1. Now, notice the top. Remember, you always have to check to see if anything can refactor. Well, notice the top is one of those fun difference of squares ones. So difference of squares, remember we're getting that plus minus relationship, x plus 1, x minus 1. And now the really fun thing is, look at what happens. The x minus 1s can actually end up canceling out, leaving us with something really nice and simple. An x plus 1 on top, and an x minus 2 left on the bottom. So again, that's why I find these so fun, because you can start with something so complex, and you can end up with something really simple, just x plus 1 over x minus 2. So that's kind of the gist of what we learned yesterday. Well, today we're learning about a complex fraction. Well, complex fraction is a rational expression that has a fraction as its numerator, denominator, or both. It can be simplified by doing the following. So we're going to find a common denominator on top, get a single fraction. Get a common denominator on the bottom, get a single fraction. And then we're going to multiply by the reciprocal. Okay, so this is one of those things. These can take quite a bit of work, quite a few steps. But in the end, I think you'll notice they're not too horrible. It's just quite a bit of work to get there. So we're going to start with this thing right here. Now I'm going to scoot it over so I give myself some extra room. All right, so 1 over x plus x over y equals 1 over y plus 1. So again, kind of nasty. Now I'm going to focus merely on top first. So I'm just going to focus on the top piece. Now again, what you want to do is you want to find a common denominator for the top. Okay, you want to turn the top into a single fraction. Well, what does that mean? Well, that means here I'm missing a y over y. Okay, over here I'm missing an x over x. So again, you're still filling in the missing pieces because the common denominator here, hopefully you can see the common denominator is going to have to be xy. All right, so that's how I knew the one side needed the y, the other side needed the x. And so what am I getting as a result of that? Well, I'm getting y plus x squared. So I'm going to write that over here. Y plus x squared over xy. Now, I want you to extend this out, make a very harsh fraction so you know now we're dealing with the bottom. All right? So on the bottom, we have 1 over y plus 1. Now, to get a common denominator here, well, the 1 isn't even a fraction. So it doesn't have a bottom that we even have to worry about. So that means the 1 over y is already fine. And that 1 just needs a y over y. So what does that mean? Well, that means our common denominator is just y. And on top, we're getting 1 plus y. All right, so we have 1 plus y over y. So we have two fractions being divided. Well, we need to think, what does that mean for us? Well, for two fractions to be divided, what that means is we can multiply by the reciprocal of the second one. All right, so just so it doesn't get too messy up here, I am going to erase all of this. So I'm going to multiply by the reciprocal of the second one, because you know that's how we divide rational expressions. So times the reciprocal of the second one. I'm going to put my parentheses around there. Now, the cool thing that I notice is look at this. Y over y, that piece actually cancels out. So the neat thing, on top, we have y plus x squared. Then on the bottom, we just have x times 1 plus y. And there we have it. That is going to be the simplified form. So again, it's a multi-step process, but if you're good at everything we've been doing so far, it's actually not that bad in the end. Again, you just have to apply many of the skills we've already done. You have to apply adding fractions and you have to apply dividing fractions into these rules. So let's take a look at another example. Now, this next example is nice because our numerator actually doesn't have a fraction in it. So we only have to worry about getting a fraction in the denominator. So 1 plus x, 1 plus y. Well, if you think about it, our common denominator is again going to be xy, which means this is missing a y over y. That's missing an x over x. So we end up with a y plus x sitting there. So we have x over, and again, really accentuate that fraction, over y plus x over xy. And again, when you're dividing by a fraction, remember that is the same thing as multiplying by the reciprocal. So I'm going to erase all this so my work doesn't get too messy. So multiplying by the reciprocal. So here I'm going to call that just x over 1. So when I multiply by the reciprocal, you can see how things are lining up. Oh, I'm sorry, that would not be the reciprocal. So if I want to simplify this a little bit now, on top I have x times y. Well, x times x will give me x squared. So I get x squared y on top. Then on the bottom, I just have that 1 times y plus x. So I can just leave that as y plus x. And that is going to be my simplified complex fraction. All right, our next example. So, for our next example, and again, I'm probably going to need some more space, so I'm going to erase that for us. So, here is our next example. So, I'm going to focus on the numerator first. So 2 over x plus 3 plus 4. Now, notice the 4 doesn't even have a fractional piece. So it's not contributing to the common denominator at all. So the common denominator is just x plus 3. All right, because it's not contributing anything else to it. That also means that the 4 is the only thing really missing anything in that common denominator. So I'm going to multiply top and bottom by that x plus 3. So I'm getting 2, then I'm getting plus 4 x plus 3 from the second side of it. So that'll give me 2 plus, if I distribute that, 4x plus 12 over x plus 3. Or in the end, that's giving me 4x plus 14 over the x plus 3. So, again, I'm going to solidify my fraction there. And then I'm going to put that on there. 4x plus 14 over x plus 3. Now, that's just my numerator, okay? I also need my denominator to have a common denominator, to be a single fraction. So that's going to be my next step. Now I'm going to focus on that denominator. Now again, the 2 isn't even a fraction. So what that means is it's not contributing to a common denominator at all. So if it's not contributing to it, that means it is the only thing missing something. So I'm going to have to multiply it top and bottom by x plus 3. So that means from the first one I get a 5. From the second one I'm subtracting 2 x plus 3's. So I'm getting 5 minus 2x minus 6 over x plus 3, or that turns into negative 2x minus 1 over x plus 3. All right, so this is what I mean by it's not difficult, it just takes a lot of work to get there. Because now I look at this, and now I need to divide those two fractions. So again, so I have some space, I'm going to erase what I have over here. To divide two fractions, remember you multiply by the reciprocal of the second one. Multiply by the reciprocal. Now notice x plus 3, x plus 3. So the neat thing is for this one, that actually cancels off. So all I have left is the 4x plus 14 over negative 2x minus 1. And if you wanted to simplify this even more, I can pull a 2 out on top. And I can pull a negative out of the bottom. Now, notice even when I do that, nothing really nothing cancels. But if you remember, it is always nice to put things in completely factored form. And that is how we can leave it. That's going to be the simplified version of this complex fraction. All right, now I'm going to save the word problem, okay? I'm not going to put in the video. I'm going to save that for us to do in class together so we can have a good conversation about it. So I'm actually going to let this be the end of our notes, all right? So please make sure you have everything written down. If along the way I was going too quickly, please do go back and catch all the notes to have them written because every step is super important to these problems. So again, thank you for joining me and come back ready to do your practice work.